Okay, so we'll pick back up with number 4 now. And we want the perimeter to be at least 48, so we set it up the same way as we did number 3. Solve when we get the W must be greater than or equal to 10. So then it asks for the smallest possible dimensions. So the smallest one for the width would be 10, because that's the equal to, so it would be 10 by 14. Any questions on number 4? Okay, number 5 is the 3 consecutive integers whose sum is 71. So I let the first integer be represented by x, so the second one would be x plus 1, the third would be x plus 2. So the first integer plus the second integer plus the third integer equals 171. And we solve that and we get x is 56. So they're 56, 57, 58. Now, if I was taking the SAT and this question was on the SAT, would I write out an equation and solve? No. Who can tell me what I would do? Okay, what do you think?
You would divide 171 by 3 and then take whatever number that is, which is 56, and then, no, it's 57, and then you subtract 1, and then you add 1, and so you take.
Very good. 3. She is absolutely correct. If you have consecutive integers and you want to find the middle one, you just take the number of consecutive integers and divide by how many numbers you have. So, we would take the sum and divide by how many consecutive integers we have. So we take 171 divided by 3 would give me 57. It would give me the middle integer. And then I just add 1, subtract 1. So if I wasn't being tested on can I write an algebraic model, I would do that. If we had a sum of 5 consecutive numbers, what would you divide by? 5. And that would give you the middle number. Okay? Alright, let's take a look at the next word problem. Okay, so 4 consecutive even. So I let x represent the first even, and then x plus 2, x plus 4, x plus 6. And so when we add up our even integers, we get 244. And when we divide and solve, we get 58. So it's 58, 60, 62, and 64. Number 7. Alex has twice as much money as Jennifer. Jennifer has 6 less than Shannon. Together they have 54. How much money does each have? Okay, I let x be represent Shannon, because when I was reading it, I was like, okay, Alex is based on Jennifer, and Jennifer is based on Shannon. So that's my starting point, Shannon. Now, last period, somebody let their variable represent Jennifer, which is totally fine. We could also do it that way. How many of you did it this way? Only 1? 2? Only 2 of us think the same. 3? Okay, so did y'all let your variable represent Jennifer? Yeah? Okay, let's do it again down here, letting the variable represent Jennifer. So if we let Jennifer be represented by J, then Shannon would be what? J plus 6. And Alex would just be 2J. So we could do it that way. We could solve for Jennifer and do the problem in terms of Jennifer. I did it in terms of Shannon. Usually I do it in terms of whatever the question asks. But this question is to find all of them. So we got to pick. If the question had said, how much money does Shannon make? Then Shannon would definitely be X. Or if the question said, how much money does Jennifer make? Then I would let Jennifer be represented by the variable. All right, any questions on this one? Okay, and then the last one. There are 3 exams in a marking period. A student received grades of 75 and 81 on the first 2 exams. What grade must the student earn on the last exam to get an average no less than 80 for the period? So the way we find an average is we would take the 3 exams, add them up, divide by 3, and that gives us our average. We want it to be at least 80, which is why we chose greater than or equal to. And so I took what they made on their first exam, plus the second, plus the third, we don't know, so we use our variable. Divide by 3 equals 80. And then we just solve this. So we multiply both sides by 3, combine like terms, subtract 156, and we get that the student needs to make at least an 84. Now, if this were not on a can I write an equation or inequality to represent the situation, I would not have done it that way. I I would have gone, okay, they want to make at least an 80. The first test was 5 points lower than that. So I'm down 5. The second test was 1 point above. So I'm a little closer. The 1 takes 1 away from the 5. Now I'm just down by 4. So the third test needs to be over by 4. So 80 plus 4 would be 84. That's the way I would do it if it wasn't. Can I write an algebraic model for this situation? Make sense? Okay? Alright, today we're going to study literal equations. So take out your explorations book and turn to page 60. Coordinate algebra explorations. Somebody asked last period when we're going to get our textbook. I will give out the textbook for coordinate algebra next week. And I'm going to hold on to the geometry. You will end up getting a geometry book, but probably not until February. And when we need it, that's when I'll collect, well, I probably will not collect the coordinate algebra. I'll just assign the geometry. The reason I'll let you keep the coordinate algebra is because you'll need it to prepare for your end of course test. Yes, ma'am.
Do we have to bring the textbook to school or like
We talked about that. Eventually, I will be giving you the codes to get online to where when you're at home, if you have computer access, you can look up any of the homework. So you wouldn't necessarily need your book at home unless your parents like to look at it with you and help you prepare. I don't know if any of your parents do that. Some parents like to do that. But they can look on the computer too. I would suggest leaving the book here. That way when next week when we start instructional focus, you'll go back to your 5th period teacher right after this class. And unless you need specific help in there, you can just work on homework. So it might be nice to have your book in case we have homework out of the book. That's my only thing about leaving it at school. Or if you have technology where eventually as soon as I give you the code, you could just look it up on the technology, that'd be fine too. Okay. So did your teachers tell you on Monday you don't go to homeroom, you break the first period?
Yes.
Your first period teachers remind you? Okay. Maybe they'll make an announcement on first period too, on Monday, about going straight to first period. Okay, so today we're going to deal with literal equations. And so our equations today will mainly be made up of variables. We have a lot of variables. And all we're going to do is take it to where it's solved from one variable and rewrite it in terms of another variable. That's all we're doing. So our first equation here, we have a times x plus b equals c. So this equation is currently solved for c, isn't it? Because it says c is equal to all this stuff. So now we're going to rewrite it and solve it in terms of x. So we're going to use the properties of equality that we've already studied to solve for x. All right, so what would we need to do to get x by itself?
You need to first divide what's
We
in
would-
the parentheses by a.
Okay, so we're going to divide by a. Very good. Divide both sides by a. That is the division property of equality. And so that will leave us with c over a is equal to x plus b. Page 60. Somebody else asked, how do I know when I need what book in class? If you look at your calendar, I have typed on there when we'll need the books, when you'll need the workbooks, when you'll need the books for class examples and homework. All right. And now we want x by itself. So what's the last step? Subtract b. So we end up with c over a minus b, and we use the subtraction property of equality. And now it's solved in terms of x. Okay, this is a formula you should be familiar with. Not really a formula, it's more of a form. It's slope-intercept form of an equation of a line. Currently it's solved for y. I'd like you to take and solve for x. You try. in the margin there. All divided by m, or did you write it y divided by m minus b over m equals x? Okay, so both of these are equivalent, and those are both fine. You could write it either way. So what did we use? We used the subtraction property of equality and the division of equality. Any questions?
Yeah.
Yeah.
I divided m on both sides first. So
Okay, if you divide by m first, you have to be careful. When we're solving, we're going to do just like we would with an equation. So if I gave you this equation, 5 equals 2x plus 3, what would you do first?
I didn't follow the steps. Silly man.
Okay, so you would subtract 3. Well, the same way you would subtract the b. Does that make sense?
Yeah, I normally
Okay.
don't make that mistake.
That's okay. That's okay. If we did, dividing by m is not wrong, but if we divide by m, we have to divide every single term by m, and it would look like that.
Yeah.
So it's definitely not wrong. You just have to make
My
sure you
answer
divide.
is wrong because I didn't
Okay,
divide
you
it.
didn't divide everything by it. It would look like that. A little different. Not the order we're used to, but it can be done. All right. Let's flip over to page 61. Okay, the formula volume equals length times width times height gives the volume of a rectangular prism with a length of L, a width of W, and a height of H. Now we're going to take this formula and we're going to solve for H. So if we knew the volume and we knew a length and a width, could we find the height that we needed it to be? And that's what we'd be solving for here. So if we're solving for H, what needs to go?
Z, L, W.
L and W need to go. And currently they're multiplied times H, so what's the inverse operation of multiplication?
Division.
Division. So we divide by the LW. Okay, the next one gives us the formula for potential energy. E equals 1/2 kx squared gives the potential energy E of a spring with a spring constant K that has been stretched a length of L. Solve the formula for K to find the constant of the spring, which gives the potential energy and the stretch. K stands for just a number, a constant. And when there are a lot of formulas that we can use, and the first thing we'll do is find the K in them. We'll get to that probably more next year that we'll start doing more of that. So here we have E equals 1/2 kx squared. And so we want to solve for K. So let's get rid of the 1/2. How do we do it? Multiply by 2. This is the multiplication property of equality. So we get 2e equals kx squared. And so we would divide by x squared. All we did here was simplify. And so now we're doing the division property of equality. And when we do, we get 2e divided by x squared equals the constant k. let's flip over to page 64 now. We're gonna start with number 5, and then number 4 I'm gonna show you, but you're not responsible for being able to do one just like it. Unless I decide to read the bonus. Who knows? Alright, the formula for the area of a trapezoid. Area equals 1/2 a plus b times h. Well, I don't usually write this formula that way. I write it this way. Area equals 1/2 the sum of the bases. I call it b1 plus b2. They just let a and b represent the lengths of the two bases. Did your teachers write it this way or this way last year? You never did it? You didn't do trapezoids? You've never done trapezoids?
Never, ever.
Oh, how sad. We'll do some trapezoids this year. We will do that. I'm sorry. Alright, so all this is new to you. Alright, we'll work with a formula here in the book. This B1 and B2 represents, trapezoid has two bases. You guys do know what a trapezoid looks like, right?
Yeah.
One pair of parallel sides, and then the other two are not parallel, but they can be anything else. It could be right there. As long as we have one pair of parallel sides, we've got a trapezoid. Okay, so there's our trap. And so this is our height here. The height is perpendicular between the bases, and then we have the two bases. Alright, so here they let the bases be called A and B. It doesn't matter really. But we're solving for B. Now B is inside here grouped with the A. So we can't move this until we get rid of the stuff on the outside. So what would you like to do first? Okay, not everybody shout out at once. Anyone? Divide by h? Okay. I'll do it. So now we have A divided by h is equal to 1/2 times 2 times A plus B. Okay, now how do we get rid of the 1/2? Multiply by 2. So this gives us 2A over H is equal to A plus B. And now we want to solve for B, so we're going to subtract A. Now, we have a capital A and a lowercase a. Do you think they represent the same thing? No. The big A represents the area of the trapezoid. The small a, in this particular example, represents the length of one of the bases. So, can't combine those. Those are not like terms. Okay. How many of you are so tempted to distribute this 1/2? Yeah? Yeah, because we've just been taught that. We've been taught that no matter what we have, whenever we have parentheses, we're supposed to distribute. Would distributing be the best thing to do on this problem I just wrote? No.
5 by 3.
If I divide both sides by 3, you see how I now made my numbers smaller? And if I had distributed, what would I have done with my numbers? I would have made them larger. Now, sometimes we have to distribute. It's the only thing we can do. But occasionally, it's nice if we don't distribute. Like on this problem right here. This is the one you're not responsible for because there's a trick to it. We're solving for W, but what's the problem? There are 2 of them. So we have to remedy that situation because we only need 1. So the first thing we're going to do is try to break up these parentheses so that we can get in there to the W's to start with. And the way we do that is first dividing by 2. So we're going to divide by 2. So we have our surface area divided by 2 is equal to our length times our width plus our height times our width plus our height times our length. Okay, so we want W by itself, so I can now move this plus HL. How do I do that? Subtract. I've got my surface area, which is divided by 2. I'm going to subtract that HL. And now I've got LW plus HW. you wouldn't have known to do. Because they have the W in common, could I write it like that?
Yes.
Do you see that if I distribute the W back in, I get what I started with? So this is called factoring out the W. It has two factors now. We factored out the W. Now, we're going to want to divide by this in just a second. So let's talk about what would make it easier. Do you see I have the surface area divided by 2? Is that the same as 1/2 times the surface area?
Yes.
Okay. Can I write 1/2 as 0.5?
Yes.
Alright, let's do that. 0.5 SA. That is a really large zero in comparison to everything else. There we go. And then divide by L plus H. So 0.5 times the surface area minus the height times the length divided by the length plus the height equals the width. Okay, now I have a couple examples that are not in the book. The first one is a U-try, because this is an equation that is in standard form. It's an equation for a line, isn't it? You had these on your summer work, didn't you?
Yeah.
And I made you put them in slope-intercept form, so I made you solve them for y. So you can already do this. Let's do it. You can do this on notebook paper. You can do this in the margins.
You want us to solve both of it?
No, I want you to hang on the second one just for a second. Did you get that?
Yes.
Yes.
Great. Okay, so you may have subtracted the 2x. And then negative 3y equals negative 2x plus 12. And then divide everything by negative 3. Huh. There. Okay, our next equation. A equals R divided by 2L. And I chose this one because the variable that we're solving for is currently in the denominator. So to solve for it, we have to get it out of the denominator. Now, when I first just stare at that, it makes me think proportion. Does it make you think proportion? Do you automatically do this in your head? And you want to cross multiply and solve?
Oh, yeah.
Okay. Well, when I saw that, since there were no addition or subtraction, and this was a fraction, that's exactly where I went first. So if I were to cross multiply, I get 1 times R is R. And so this gives me 2 times A times L. And I want to solve for L, so what would I divide by? 2A. So that was my first thought. My second one was, well, what if my students look at it and they don't think it's proportion? What would they do? So what you might be thinking is, I need to get this L out of the denominator, and since it's being divided, I should probably multiply it. So now I've got L times A Okay. All our brains work differently though. Some brains work, like my brain, it really works in strange ways. Like I never subtract, I always add backwards. Y'all do that? Nope, just me. Great. Okay. Here we go. A slightly more complex one, and we're solving for z. Alright, so Matt, Stalzer, what do you think we do first?
Multiply both sides.
Yes, we do. Very good. We're going to multiply both sides by 4. So that will give us 4x equals 2y minus z. Now, there's a couple things we can do at this point. Since we know we're solving for z, and we want z to be positive, we can move it over here, and then the 4x over there. Or you can move the 2y over and divide by negative. You go either way with it. I would probably move the z. And so I get z plus 4x equals 2y, and then subtract the 4x. So I get z equals 2y minus 4x. Either way is totally fine though. You can subtract the 2y and divide by the negative. Any questions? Okay, this is a formula we're going to be using at the end of this year. This is the formula to find the area of a sector of a circle. And a sector of a circle looks like a piece of pie. Okay, it's got the curved outside and it looks like a piece of pie. So this is the area formula for the sector of a circle. Degrees over 360 times pi r squared. Well, this has us solving for n, which represents the degrees of the central arc. And what would I do to get n by itself? Okay, Ryan.
You would multiply 360.
Yes, you would. Okay, and then what?
360a, and then you divide by pi r squared,
Yes, you do.
and then
You're done. Beautiful. Whoops, left out the a. So we get 360a over pi r squared is equal to n. And n represents the number of degrees of the central angle. Okay, one last you try problem. If you can do this one, then you get to start on your homework early. And we won't do any more examples. T equals 1/4 times a minus 3b. Solve for b. So we're solving for b. We got to move that 1/4 by multiplying by 4. So we get 4t equals a minus 3b. Subtract the a. So we get 4t minus a equals negative 3b. But when we divide by negative, we're not going to leave the negative in the denominator, are we? We're going to distribute it through the numerator. And when we do, it's going to make the, let's change colors. When we distribute it through, it's going to make this negative and this positive. So more pleasing if we start with a positive a. So a minus 4t, all divided by 3 equals b. Are we good?
Yes, ma'am.
Okay, your homework is on page 65. Ready to circle numbers? Circle number 1, 2, and 6, 8, 9, and 10. And then 66 all. 1 through 8. 1 through 8 on page 66. So 65, 1, 2, and 6, 8, 9, and 10, and 66, 1 through 8.
Can we just check on the here? Or you can check our, or can we be like, on here? Are we not gonna use that? Okay, you can,
I will check wherever your work is.
okay, alright.
Well, you be ready to show it to